The word science derives from the Latin scientia, meaning knowledge. And that's what science is all about, isn't it? It's about knowing things. But how do we really know anything? If I were asked a question, if I know what would happen if you take vinegar and baking soda and put them together, I would confidently answer that we will see some bubbles form. How do I know this? First of all, because I've done that a few hundred times in my life, I've judged endless science fairs where students have made baking soda vinegar volcanoes. And there's never been an instance when you've taken some vinegar and added some baking soda and not seen bubbles. So, of course, I know what happens. And I also know the chemistry. I know that if you take acetic acid and sodium bicarbonate, you release carbon dioxide gas. All right. But what if I were asked a different question? What if I were asked what happens if you take a hammer and a feather and drop them simultaneously on the moon? I haven't been to the moon. Would have liked to go, but haven't been there. But I can still give a confident answer. They would hit the ground at the same time. Now that sounds surprising, right? Because obviously this is heavier, it's greater mass than the feather. You would think the hammer would hit the ground first. And that's what Aristotle suggested a couple of thousand years ago, because it just makes sense. He would have dropped the hammer and a feather, and the hammer would have hit the ground different times. But you know what? We can show that Aristotle was wrong in a very simple way. All we need are two pieces of Kleenex. Now, obviously, they are of the same mass. So if I crumple this up, I have not changed the mass. Aristotle would have said that, the larger mass hits the ground faster. But if I take these of equal mass, right, and drop them at the same time, the crumpled one hits first. Why? Because of air resistance. On the moon, there is no air resistance. So the two should drop at the same time, just like Galileo showed. Well, I don't know if he really did take two cannonballs up to the Tower of Pisa of different masses and drop them to show that it hit the ground at the same time. But he did carry out experiments to prove that that would be the case. So I know that the two would hit the ground at the same time on the moon. And in 1971, astronaut David Scott on Apollo 15 did this classic experiment on the moon, and the video evidence is there. They hit at the same time. All right, so that's how I know that as well. But what if I were asked the question of taking a glass of tap water? Would I worry about the fact that it contains trace amounts of perfluoroalkyl substances? Well, we know that it does. We can measure that. It might be in the part per trillion range, but we can determine that. Does it have any kind of effect on my body? Well, I can point at studies that show that if you go into the lab and do experiments with these chemicals on animals or on cell cultures, they have an effect. But does that mean that if I take a sip out of this, it's going to have some effect on me? I can't tell you for sure, because the experiment that would tell me the knowledge for sure cannot be done. You would have to have two groups of people drinking tap water over decades, where one tap water would be free of these chemicals and the other not. You cannot do that. So we have to make educated guesses. I can't say for sure that I know. I can say that I don't think that the trace amounts in there can have an effect, but I can't tell you for sure. And that's how science works. Some things we know, some we cannot know. How do I know that the earth is round? Because this ball has been sitting on my desk for decades. It's the earth, and it's round.